Hi everyone, this is my translation of the series I created originally for my overseas audience, but since I noticed some interest from my Silicon Valley community, I decided to quickly translate it. At the beginning of this video, I want to highlight that in the description of every episode on our channel, you can find links to the source code. Today we'll make a few small updates to improve our program for engineers. Let's make it a little smarter and cleaner. Engineers love that balance, huh? In the very first episode, we built Test Station 1. If you haven't seen that video yet, please watch it before you start working on these improvements. The link to that episode in the description. To make things closer to real-work situations, we'll now use not one table in the database, but a separate table for each test station, since engineers will have multiple stations. That's how it works in production. One setup never fits all. I have the project open. In the project folder, we copy the file called Test Station 1, rename it to Test Station 2, drag it into the project, save everything, save all, this project, and open it. Previously, this program was built for a single test station called Test Station 1. Now we'll make it universal for multiple stations so that each engineer can assign a number to their station and accordingly a table name in a database where their data will be stored. In other words, every engineer gets their own digital sandbox. No data collisions, no chaos. To do this, first we remove the number 1 from the name and add a ring, where we'll list the names of these stations. This way, each engineer can choose which database table to record their data into. It's like giving every station its own inbox, clean and organized. On the front panel, go to Classic Ring and Enum System Ring, place it and open Edit Items. Here we type the names. The first one will be empty and the second will start from Test Station 1. We'll create 5 tables total. Test Station 1, Test Station 2, Test Station 3, Test Station 4, and Test Station 5. Press OK and check. Everything looks right. We have a menu of options. We need to fix these values so they remain default. So go to Data Operations, make current value default. Rename the ring to Test Station Table and move it above the Send button to fit the overall layout. Open Properties and set the width to 110, same as the Send button, and align all buttons on the left edge. Everything here is ready. Let's save it. Good UI is like good engineering. Symmetry matters. Now, let's open the block diagram. Here what we had after the first episode, when we originally built the first test station. Now we can see our test station table ring. We'll open the case structure, go to the false case, and place the ring inside. From it, we go to Create Property Node, and we'll need strings along with a select property value. Strings represent the array and value represents the index. From array, add index array and connect it to this function. Input array strings, input index value. Next, we click on the global variable on and find global definition. This opens a hidden subdiagram. Here from NXG style, we select string and path. String control, rename it to database DB table, save it and close it. Hidden subdiagram, it's like LabVIEW's version of behind the scenes. Now let's copy this global variable, select database table from it, and connect it to the output element in the index array with the global variable database table. Then from comparison, select the not equal function and add an empty string constant. Connect it to the not equal function and also wire the global variable into it. This logic keeps things clean. We don't want to send data into a void. Next, we enclose all of this in a case structure and add another case structure for the global variable. Here, we'll also create a message for engineers. So we connected the case selector of the smaller case structure to the not equal function. Now, from array, let's add a string function, concatenate strings, expand it, and add the following. The first string constant is a message send data to. The second string is a carriage return constant, line break. And the third string is the global variable database table. Then from Dialog and User Interface, select To-Button dialog, which automatically connects, as you can see. Let's check what this function does in Context Help. Hover over and read. To-Button dialog displays a dialog box that contains a message and 2 buttons, OK or Cancel. Programmers love dialogues, especially the ones that don't crash. Now, disconnect the onGlobal variable from the old connection and move it inside the new case structure. Connect the trueButton output of the toButton dialog function to the onGlobal variable. For the false case, we also connect it, and from the menu, choose Use Default if unwired. Now, let's create another message for the false case. From Dialog and User Interface, select OneButton dialog. In the message, create a constant and type Choose Table. That's it. If only life had a one-button dialog, everything would be so much simpler. Finally, we connect the Boolean button, send to DB provider, to the new case structure with the case selector, and save. By the way, about the one-button dialog, it's all self-explanatory, but we can still check the difference in context help. We use two-button dialog and one-button dialog. One-button dialog displays a dialog box that contains a message and a single button. It's clear and straightforward. And yes, every engineer has clicked OK before reading the message at least once. So, what did we just build? We created a simple logic flow. When sending data to the database, the program checks whether we've selected a table in the ring or left it blank. If it's blank, a message pops up, choose table, prompting the engineer to pick one. Now, when we run the program, set the number of records, measure the data, and decide to send it, we click send, then choose table message appears. We click OK, select the table, let's say table 4, and click send again. Here comes the extra verification. If an engineer accidentally picked the wrong table, which happens, we give them a chance to fix it. A dialog with the two button appears. OK, continue or cancel. If they press OK, the data is written into the table via the database provider program. Mistakes happen, that's why we automate checks. And if the table doesn't exist yet, the database provider program automatically creates it. We'll explore that in the next episode. For now, just a reminder, the source code for this episode's program can be found in the video description and the first comment pinned as well. And remember, good code, just like good coffee, should never be overcomplicated. Thank you for joining LaPlante Tech. If you have any questions, please leave them in the comments. If you learned something new today, give this video a like and subscribe to stay up to date with upcoming episodes.